Welcome back. In today's video, we want to design a difference amplifier that has a differential gain of 100 and an input resistance to ground of at least 10K at each input terminal. So first, let's draw our complete difference amplifier circuit with our attenuation network. And here's our feedback network and our second input voltage signal. So the first order of business is to use superposition to find the output voltage, V out. By setting V1 equal to 0, we then get a inverting amplifier configuration. So that first portion is going to be minus R2 over R1 times V2. Then by setting V2 equals to 0, we get a non-inverting configuration. So the voltage at V plus, let's just write that down first. The voltage at V plus is going to equal to the voltage across R2 by voltage division. So here we can see that we have a attenuation factor attenuating the voltage signal V1. For a non-inverting case, we know that the output voltage will equal to R1 plus R2 all over R1 times V1. Here we can see that V1 should be attenuated by our expression here. If we include that into this expression, we then get R2 over R1. So there we have R2 over R1 times V1. So V out is then equal to a common gain factor of R2 over R1 multiplied by the difference between V1 and V2. So that is V out. Also, we would like to figure out, in this case, where would we have our input resistance? Or say, for instance, let's just go in the right way. So we know that our in both cases, so let's just use a different color. So the current I in we have 0 amp going into V minus, 0 amp going into V plus. So we can see that the input resistance R in is equal to V in over I in. I in is V in over R1. So V in over R1, which is just equal to R1. So the input resistance for both cases is R1. So that means we should choose R1 equals to 10 kiloohms. Because here they ask for a input resistance of at least 10 kiloohms. If we choose our input resistance to be 10 kiloohms, we can then find our R2 resistor, which is going to equal to, so let's just write the equation for the voltage gain over R1. So we know that the voltage gain is 100, and thus we can get R2 to be by 10 kiloohms. So R2 is equal to 1 megaohm. So then R2 becomes 1 megaohm. So here we design a difference amplifier that has a differential gain of 100 and a input resistance to ground of at least 10K. So our input resistance is 10K. By using R1 and R2, the ratio gives us a voltage gain of 100. And here we design our difference amplifier. So that was a quick and easy problem. So I'll see you in the next one. Bye.